Hello everyone, welcome back to the verification lab. In today's lecture, we are going to discuss data type in SystemVerilog, one of the most fundamental concepts for both design and verification. Understanding data type is very important because it defines what kind of data we can store, how it is represented, and how it behaves in the simulation. So, what is a data type? A data type defines three main things: the type of value a variable can store, the operation that can be performed on that data, and overall representation and the behavior of the data. In simple word, data type tell us what the data looks like and how it behaves. So let us first understand the representation aspect, meaning how data is stored. So while storing, we need the size of the data. For example, what is the bit of the data? So here 7 down to 0, that means 8 bit. So it can store 8 bit of data. Now, what value can a data have? So if it is in two state, so it has a value 0 or 1. So it is defined by state type. And if it is a 4 state, it can have 0, 1, X and Z, where X and Z, X stand for unknown and Z for high impedance. Data can be negative. So negative data are represented by signed, where data can have positive, so it is represented by unsigned. Then data category, if it is in fixed or user defined. If it is in fixed, then integer type. If it is in user defined, then it's a vector type. So in vector type, user can define the size of the bit. Then we have packed as well as unpacked. So packed are used to define the continuous bits like hardware representation. You can see here data is represented from bit B7 to B0. They are all continuous bits. Where in unpacked, they are not continuous. They have separate memory location like arrays. Now we will see the behavior aspect, how data behaves. So if it is in variable, it can store value. If it is in NAT, it can drive continuously and it is used to connect different module in an RTL. So basically for connection, driving or driving continuously. For example, assign y equal to a and b. If a is changed, y is changed immediately. But if it can store and update later, so it will be like variable. So the different behavior lead to different variable or net declaration. Then we have assignment type. So if it is in procedural assignment, then we can use one type of data type. While if it is in continuous, we can use different type of data type. Initial and always block are procedural. That means the program or the code written inside over it will execute sequentially, where continuous assignment are concurrent in nature. So if we have 5 statement, 5 of them will run parallelly. Then we have lifetime. So this behavior of the data type give us an idea of like lifetime of the lifetime of the data. So if it is static, so data in various call have same memory location, while if it is an automatic, data in various call have different memory. Then we have drive resolution. So that means that net can have multiple driver. In two different initial block, we can drive multiple driver and the resolution conflict. So we have some rules governing how to resolve if there is a conflict. Now we'll see some advanced, or we can say user level feature of data type in SystemVerilog. First of them is user defined data type, that is enum, struct, union and class. As of now, I am going through the surface level of each and every concept. It is an overview session. I will take practical session as well as more detailed theory session on each and every concept discussed over this slide. We have data abstraction, that means grouping related signal. Like we have struct as well as union, which improves our readability and reuse. Then we have casting or type conversion, which can be explicit as well as implicit. And it is the technique by which we convert one data to other. And we have compatibility rule. We cannot convert any data to any data, different data. So there are some rules. Those rules are the compatibility rules. We'll go through the rule when we are discussing the compatibility or typecasting topic. Now let us see the roadmap. So this is for the data type series. So what will be the roadmap? We'll start with integer data type. Then we will move to the real data type. Then we will see net versus variable type. Then we will see void. Then we will see vectors and arrays. Arrays I will explain basic in this data type lecture. So to understand packed and unpacked, again in the arrays session, I will explain in depth of the arrays. Then we have string as well as event type. Then user defined data type. Then enumeration. Then constant and parameter. Then scope and lifetime. And last, typecasting and compatibility. Now look at the integer type. So we will start with shortint. Then we have int. Then we have longint. Then we have byte. Then we have bit. Then we have logic. We have reg. We have integer. We have time. Now let us look about the description of each of these data type. So shortint is a two state. Two state means we can store 0 or 1. Signed, it can store positive as well as negative value, and 16-bit, that is it is fixed. We cannot change the bit width. So it is 16-bit. Similarly, we have int, only difference is 32-bit. Similarly, we have longint, only difference is 64-bit. Then we have byte. So byte is 8-bit. Then we have logic. So logic is unsigned. Then we have bit. So bit is an unsigned user defined vector size. So size is dependent upon the user and it is unsigned. Then we have logic. It is 4-state data type and it is unsigned as well as user defined vector size. Then we have reg, same. Reg was an old data type taken from Verilog. So what is the difference between reg and logic? We will see in the practical session. Then we have integer. It is also an old data type taken from Verilog. Then we have time. It is unsigned and it is 64-bit. In simulation, in test bench, if we want to see the timing value or if we want to print the timing value, we will use time data type to store the timing information. Now let us see about the signed, unsigned and its range. So basically if we see signed and its range, so it starts from negative to the power n-1 to the power n-1 minus 1, where n is the number of bit. So if you see here int a, the MSB 31 is dedicated for the sign bit and rest 31 bit are for the value. And if we see about the unsigned and its range, it starts from 0 to the power n-1, where n is the number of bit. Now let's move to the real data type. So real data type has real, shortreal. So real are the data type and which can store decimal value. So 64-bit floating point if we use only real, and it is IEEE 754 double precision standard. Then we have shortreal, it is 32-bit floating point IEEE 754 single precision. Now let's see real shortreal IEEE 74-bit representation. As of now, I am not going into the depth how a value from decimal is converted into bits in real. So I will make separate lecture on the conversion details. As of now, I am giving an idea. So if it is 64-bit, as we have discussed earlier, so MSB it is dedicated for sign. Then we have 11-bit for exponent and rest 52-bit for fraction for 745 double precision. Similarly, if it is shortreal, we have single precision. For single precision, MSB 32-bit is for signed, 8-bit for exponent, and 23 bits for fraction. So now let's move to the limitation of the real. Real data type has some restriction. So first restriction is cannot be used in edge event control. Post edge, neg edge are not allowed for the real data type. Bit select or part select are not allowed. You cannot write real variable 3 or real variable 7 down to 0. So these are bit select and part select. These are not allowed in real data type. Real values cannot be used as an index expression. So you cannot use as an array index. So real is mainly for simulation level modeling only. That means we can say calculation and modeling. Not suitable for hardware representation. SystemVerilog provide conversion function. So first conversion function is $R2I. R stand for real to integer. So if we give any real value, it convert real value to an integer. Each of these I am explaining only the theory. Practical I will be explaining in the EDA playground in the upcoming session. ITOR, it is a reverse. We put an integer value, we get a real value. Real to bits. So if we put real value, it will convert to the IEEE 7454 double precision format. Similarly, it is reverse. If we put the bit value, it will convert to real. Earlier it was for real, now we are doing for shortreal. Again, single precision conversion. If we put the shortreal value, it will convert to shortreal to 32-bit vector. Again, we have bits to real. So if we have bit value here, it will convert to real. So it is in reverse of short to real bits. These are very useful when converting between formats. If you want to change the format, so these functions are useful. So that's all for today's lecture on data type in SystemVerilog. We covered representation, behavior, integer type, and real type. And if you found this lecture helpful, don't forget to like, share, subscribe to the verification lab. In the next lecture, we'll continue with more advanced data type. So stay tuned for that. Thank you.